Hi all, welcome to the session. We are in the process of understanding various metrics in the classification. In the earlier session, we have seen the aspects related to the regression. Now we'll see the aspects related to the classification. Basically, if you observe the kind of the classification, okay, so of course it is belonging to the supervised learning. Many at times we have seen uh, these supervised learning, the basic kind of the algorithms belongs to the classification. It gives either yes or no or true or false. Okay, whatever the classification techniques we follow, at the end of that model, we'll get some yes or no or true or false kind of the considerations. Now the point is, friends, here, of course, in the classification, again, just I am referring to, we have seen some k nearest neighborhood, support vector machine, naive Bayes, decision trees, and then we have seen some random forest. Okay, all these are the considerations related to the uh, classification mechanisms, and of course, logistic regression is also there. I'll talk that some other time. So this logistic regression is having some differentiation compared with other techniques. Okay, so I'll scope that discussion in a separate discussion. Now, as we are talking about the metrics, because we are getting some 2 to 3 questions in this metrics, uh, just if you are referencing the metrics of the classification, you should be very clear about understanding of these metrics. Because in the Databricks certification, just we are getting some sort of questions like they will be giving some scenario, and according to that scenario, we need to identify which metric is suitable to that. So in that particular case, the first basic thing is the confusion matrix, and second thing, which is the accuracy, and third one is nothing but precision. Next one is the recall, and some other aspects are also there, AUC, ROC. Okay, these are all some of the metrics related to the classification. And if you are moving a little ahead, guys, in the earlier session, if you observe the aspects I have covered along with the metrics of regression, okay, we are having these things actually. Classification, the performance matrix, confusion matrix, accuracy, precision, recall, and F score. In that particular case, friends, we have seen some sort of confusion matrix where that particular matrix helps us to identify both correct entries and as well as the incorrect entries. Most important point here is, guys, while implementing any kind of the model, it is always important to identify whether the appropriate thing is correct or incorrect. Both the things definitely helpful. So in that case, just we have seen true positive, false positive, true negative, false negative, all these kind of the things. Okay. So generally, if you are making use of these kind of the considerations, we are having some sort of mechanism where you can get these correctness, true positives, and true negatives. These two are the correct measures, and remaining are incorrect measures. And coming to the accuracy, in the earlier thing we have seen, accuracy focus on ratio of the correct predictions. Ratio of correct predictions in the sense total predictions maybe 100, correct predictions maybe 10. Okay, maybe 10% only we could able to get the accuracy. So accuracy mainly focus on true positive, false negative by all these total predictions, true negative, false positive, true positive. You observe friends, one important point. Really this accuracy makes sense. Like only we are taking the correct cases out of all cases. Maybe I'm having only one correct case out of 199 incorrect cases. Okay, there is no scope for the incorrect cases, only correct case, and that too we are verifying this correctness through all the totality, which is not definitely the good point. Na? So suppose see one simple example. Suppose if I need to give the rating for the data engineers, maybe their implementations, projects, subject research or publications, I need to see the genre of data science, data engineering, data analytics like that. I should not go to see here all app engineering and as well as Mendix and as well as testing and maybe some other genre which is not at all relevant to our data science, data engineering kind of thing. So obviously guys, which is giving some kind of comments, accuracy, generally only it is talking about the correctness, but which is not purely dealing with the correct and incorrect formats of the data. Okay. We have seen some examples also like true positive, true negative, false negative, like how we are making use of that convention from the appropriate confusion matrix. And we can able to see that how many are how much accurate we are getting. Now the important point here is guys, the precision, which is of course most commonly used construct, which is dealing with both correct cases and incorrect cases. So precision of fall, precision of pass and precision of fail. That means what is the percentage of the pass in the total pass and what is the percentage of the fail in the actual fails. See here, this is a prediction. Of course, our model usually generates some kind of the prediction, and these are all actual data items. And maybe we are having pass or fail kind of thing, and we are having actual pass. So corresponding predictions. That means 100 pass is there. We can able to grasp 90% as pass. Okay, pass in the sense we predicted 90 times correct out of 100 correctness. So 90% precision we are having. And failure also maybe 75 cases out of 100, assume that. Failures are also there 100. So 75% is correctness we have found. Okay, out of 100 failures, 75 times we could able to grasp the correctness of the appropriate failures. So here only we are having the true positives by true positive plus false positive. So which certainly gives the understanding of the precision, maybe in terms of pass or correctness. Similarly, the failure rate, true negatives by true negative plus false negative. Likewise, we are able to generate the various measures so as to maintain the prediction. So to reduce the wrong predictions, okay, just we can make use of the precision. Okay, so that is how you can specify your precision, recall, all these kind of things, guys. So now the one more important aspect I want to cover is because so far we have seen the accuracy and then the precision. So we'll start with the understanding of the precision because we are getting some sort of the questions from here also. Your accuracy, to summarize, okay, just deal with the correctness. Whereas your precision deals with correct entries and as well as the incorrect entries. Because this is also one of the important thing where you can observe, where you can scope in the study of the model performance. So the main aim of this particular precision is, of course, to reduce the, because so this is one of the important thing, to reduce the wrong predictions. Because how many corrects are there? How it is reducing false positives and false negatives. Just to remember that point, guys, because later after completion of this discussion, we are having one some kind of the question where you can pick up the suitable measure related to the study. And one more measure is there, na, recall, that we need to study. What exactly this recall is? Probably this is the third thing, friends. Precision and accuracy. Just we have seen now. Now we are dealing with the recall. Of course, on top of these things, your confusion matrix is one where we generally use to observe the usage of true positive, negatives, false positive, and false negative. All these kind of the conventions. Now, if you observe the recall, but there is a small distinction actually. The recall, guys, just you see here, you can easily remember. Um, Total predictions of pass or fail. On top of this, we are making use of correctly predicted pass or fail. Okay, now you observe in terms of this thing, actually we have seen true positive by true positive. Suppose to compare, let me compare precision of pass, because you should not confuse true positive plus false positive. Whereas if I want to give the recall of pass, there is a small distinction. Just what we can do is with respect to these things, true positive by true positive plus false negative. This is the recall kind of thing. And similarly, if I'm giving the precision of fail. Okay, so precision of fail, how we can refer, guys? Just we are making use of true negative by true negative plus false negative. Okay, precision of failure. But whereas if I want to observe the recall of the failure, so just you can go with the recall of fail, which is of course true negative remains same. And here you can observe the appropriate aspects like true negative plus false positive. Okay, so true negative plus false positive. In terms of these things, friends, if you remember if you observe, the numerator kind of thing is same in both precision and recall. And the first thing also, true positive is also same. In the precision of the false, we are reducing the false positive. And in the recall, we are making use of the false negative. So just that there is a distinction actually. False positive and false negative. I mean to say here true positive means correct. We are only talking about the past. False positive model actually observed as that as a positive, but they are not positive, they are negative. So this is the sense. So we are only focusing on the how many times our model wrongly predicted the negatives as positives. True positive remains same. False negative, what it does is actually that is negative. False negative. Actually, the model predicted as negative, but they are positive. Simply opposite, guys. Your model predicted as positive, but they are negative. But here your model predicted as negative, but they are really positive. Just a small distinction. Here also in terms of the precision, I'll be having false negative. Just they are interchangeable, precision and recall. And this here also instead of this thing will interchange those kind of the aspects, false negative, false positive kind of thing. Don't worry, no problem. Just will you can have a look on that consideration, but definitely the precision is the one which is really helping us to understand the false positive and false negative, because it is going to reduce as that of the precision. It is also going to reduce false positives and false negatives. Okay. Now, just with this, we can have the some sort of these questions. Let me paste the question which was asked earlier. Let me pick that question, guys. Not this one. One minute. Give me yes. Yeah. Okay. So there is a question, guys. Let me pick up that question for us. Yes. Okay. This is the question we are having. Okay. These type of questions they are generally asking. A health organization is developing a classification model. Okay, so definitely they provided the clue that okay, we are working with the classification model, right? Uh, then to determine whether or not a patient currently has a specific type of infection, maybe some sort of XYZ infection we are working on. Okay, and whether he is having that infection or not, yes or no kind of thing. Of course, classification basically does that only. Okay, just it is picking up of some kind of the aspects and it is going to perform some sort of the activities. The organization leaders want to maximize the number of cases identified by the model. Maximize the number of cases. Okay, organization leader wants to maximize the number of cases identified by the model. So model come up with some kind of the positive cases and negative cases, and they want to study about these things. Which of the classification metrics should be used to evaluate the model? Okay, so which of the following? Uh, Generally, guys, if you are referencing this kind of the examples, because they don't want to focus on only positive cases and they don't want to focus on the negative cases. So obviously, pass or fail kind of thing. Accuracy is out of race actually. Accuracy only focus on the positives out of the total. But here they want to study only the number of cases identified by the model, maybe pass or fail. Then we are having two things actually. One is the precision, another is the recall. But you know, guys, in terms of the precision, what it does is just it is focusing on the pass out of how many real pass. And similarly, fail out of how many real. So this precision observes that I got some 5 members as infected, but actual infected were 5 or maybe 6, something like that, because accuracy is very important, guys, for this. So that means I don't want to miss out any lethargic or any kind of this is medical domain, guys, especially. Failure also, you know, suppose fail in the sense 4 members are not having any infection out of 4 or at least 5 maybe. So this is real and this is the model predicted. So this thing actually precision only can give the accurate measure, while the medical kind of the things, just to observe that, because accuracy only deals with correctness. It is not going aside those other kind of things. So it is only focusing on the precision kind of the aspects. Okay. But recall, you know, what it does is just it is focusing on the false negatives and false positive kind of thing where we are not interested on that, because how many times we get negatives out of the positives, that is not our theory actually. Only the thing is how many times we actually observed true values as true, false values as false. So that is the major important consideration where you can observe. So to answer these kind of the questions, guys, if those members are only concentrating on the positive, the successful kind of the positive aspects, go ahead with the accuracy. And second thing is maybe positive or negative. Out of these positives, how many real positives are there? Or else how many out of the real negatives, how many negatives we can able to observe? That is the precision actually. Excellent measure, guys. This is the precision. Recall is distinct, na? Positives, but again we are observing the kind of how many false positives are there. We are ending with positive plus false positives. Okay, this is somewhat diluting our requirement, but at times maybe is there any specific kind of the cases where wrongly predicted, or if they are making sense of that kind of thing, then you can make use of the convention of embedding the recall. But especially these medical domains, and especially in this example, our answer is precision only, not the accuracy, not the recall. Okay, so now most important thing, guys, we are getting some questions from this path also, which is nothing but encoding techniques. Okay, so most important topic, have collected some compilations related to this encoding techniques, or which is also known as categorical data transformations. Okay, I completely we are having that categorical data, what exactly that, and I will be introducing that thing. Now, if you are referencing the categorical, we pretty know that some kind of the country information or some kind of the qualifications or some sort of the blood groups. Okay, they are fixed. Okay, so if you are making use of these kind of the conventions, how do we handle these particular categorical kind of the aspects? Um, we're having some information with us, friend, because there is a lot more things to describe. Basically, we need to understand what exactly the categorical data and why we need the appropriate implementation of this transformation. Okay, there is a nice analogy I have collected. So let me pull that point so that in a quick manner, I'm going to explain these things. Now, just observe here, guys, the performance of the machine learning algorithm or machine learning model not only depends on the model and the hyperparameters, but also we process and feed different types of the variables to the model. That means, of course, we are having excellent hyperparameter tuning methodology with us, and our model is fully trained and tested. But we are one more component we need to observe is how we process and feed different types of the variable to the model. Maybe the number data or categorical data, that is the sense actually. And since most machine learning models only accept numerical variables, pre-processing the categorical variables becomes a necessary step, especially if you observe the KNN, or if you are performing some mean or something like that. Definitely that model demands the usage of the numerical variables. So obviously, guys, we need to convert these categorical variables to numbers such that the model can understand the exact valuable information. So the point is, along with your hyperparameter tuning and all these things, these categorical data transformation is also important. These are all specific points I am making here. A typical data scientist spends 70 to 80% of his time cleaning the data, preparing the data, and converting the categorical data is also the unavoidable activity, because data cleansing in the sense, as a next topic, I'll be covering that missing value imputation, which is very, very important. And pre-processing of the data, maybe this conversion of the appropriate data items into numbers, and these kind of conversion of the categorical data into the appropriate suitable conversions is also one of the important point in the pre-processing. It not only elevates the model quality, but also helps in better feature engineering. Actually, if you observe guys, feature engineering, our 90 or 80 to 90 percentage of the data scientist or machine learning engineers activity revolving around the feature engineering, maybe mapping of the data, processing of the data, all these kind of the conventions. Now coming to the actual discussion, what exactly the categorical data? So we realized that out of these particular pre-processing, conversion of the categorical data is also one of the important aspect. Okay, conversion of the categorical data. Now, if you are making use of these categorical variables, which are of course are usually represented as strings or categories in a finite number, which are in finite in number. So just by seeing that, we can easily grasp that whether those things belongs to the categorical data or not. Some examples I have compiled. So maybe the person opted to work from home, maybe Delhi, Mumbai, Ahmedabad, or Bangalore, etc. So the city where the person lives is categorical data. The department a person works, maybe finance department, HR, IT, or production. And the highest degree, maybe high school diploma, bachelor's, master's, or PhD. So just you can easily, maybe I'm having 1 lakh records, but all those 1 lakh records maybe belongs to either of these qualifications as highest qualification. Okay, so it's not varying from the 1 lakh qualifications we're having, but those 1 lakh qualifications feature is picking up these values only, 1, 2, 3, 4, 5 values only. These 5 values only repeatedly coming in this feature. And grades of a student, maybe A plus A, B plus B, B negative, etc. These are all grades we are generally give to the appropriate evaluation. Assume that. So in all the above examples, the variable only have a definite possible values. I mean, there is a kind of the boundary where I cannot give any other value, either high school diploma, bachelor's, master's, or PhD. That, like that only I have to select. And here also in the grade and all. So definitely from these particular categories only I need to pick up that. Maybe at times you may be seeing some sort of other types, friends. Even though we are talking about the categorical, in that particular categorical we are having some inherent order, maybe movie rating, or here also A plus, because these grades are having some reflection, highest grade or lowest or something. But whereas if you see the city, there is no grading actually. Delhi is equivalent to Mumbai, equivalent to Ahmedabad, and equivalent to Bangalore. There is no rating for that. Okay, practically they are all same. Okay, they are not having any ratings or something. But whereas if you see the qualifications, definitely the highest qualifications, there are some distinctions. And here also grades also they're having some order. So inherent order if they maintain, then they belong to the ordinal data. Observe guys here. In categorical kind of thing, if you are explicitly observing any inherent order, then it becomes the ordinal data. Nominal data is something like, friends, where we are making use of some convention. The categories do not have any inherent order, like this is an Delhi, Mumbai, Ahmedabad, Bangalore. All these things belongs to the nominal. Even finance department is equal to HR, equal to IT, equal to production. All we are having the same kind of the, consideration. Okay, so these things are nominal in nature. So in ordinal data, friends, as we need to preserve the order while encoding, also one should retain the information regarding the order in which the category is provided. That is the most important point. So for PhD, if I'm giving 5, for masters, if I'm giving 4, for bachelors, if I'm giving 3, then as per that particular order only the appropriate consideration should be given. I cannot put a bachelor member as a doctorate or something like that. No? So there should be some consideration. And even in the managerial positions, I assume that at least you should have some engineering degree or master degree. So like that, there is some sort of explicit condition, then you need to preserve that, friends, actually, though in the conversion process also, what I mean to say. Like in the above example, the highest degree of a person possesses gives vital information about his qualification. The degree is an important feature to decide whether a person is suitable to post or not. Because generally the qualifications, gives the kind of exposure and gives the kind of the confidence to the member, and based on the qualification we can say the eligibility criteria also. Okay, that the point here is ordinal data. Oh, sorry, we have to preserve the order of the appropriate data. But whereas in the other go, while encoding nominal data, we must consider the presence or absence of the feature, whether he is residing in Delhi, Mumbai or Ahmedabad or Bangalore. Just it is a matter of existence or not. In such case, no notion of order is present. Order is absolutely not required here because we don't want to assign any order or any higher rating for Bangalore people or lower rating for Ahmedabad. Not like that, guys. There should not be those kind of the conditions won't arise actually. So, for example, the city a person lives in, for the data, it is important to retain where a person lives. Here we do not have any order or sequence. And it is equal if a person lives in Delhi or Bangalore. We are absolutely fine if he chooses to work from either of those cities. We are not restricting him, provided we are providing them to work from home. And apart, so by this time, just you would have observed what exactly the categorical data. Clearly, I can able to observe there is a limited set of the data items where the entire records or entire data is span over with these repetitions only. And there is a in the categorical data again, maybe I'm having the ordinal or nominal data, where ordinal data is something like which maintains the order inherently. Nominal in the sense there is no order exactly. Okay. And one more thing is in the transformation, I will be talking about how many transformations are there and what exactly the procedure. Before that, just if you observe the ordinal kind of the data, where it is using it, it should preserve the importance of the order, and accordingly in the transmission also, in the transformation also, the appropriate order should be reflected. Okay, that is the ordinal kind of thing. Whereas your nominal data is something like which is not at all considering the order, just it is preserving yes or no kind of the considerations. Okay, this is how you can see the categorical data types. Now, the other important points I have collected, guys, just after getting these kind of the considerations, the first method I want to talk is just label encoding or ordinal encoding. As the name implies, ordinal in the sense, definitely we need to preserve the order. Okay, so just we'll be talking about some example and I will give you some implementation also in through Python. So just if you are referencing, let us try to understand on what basis we are going to select the label encoding or ordinal encoding. This is probably the first kind of the categorical data transformation. We use this categorical data encoding technique when the categorical feature is ordinal. As said earlier, like your BSc or BTech or MSc or MTech and your PhD, all these kind of the considerations. Okay, there is ordinal. In this case, retaining the order is important. Hence, encoding should reflect the sequence. Okay, maybe I'm giving 1, 2, 3. It means the highest rating. It follows based on the qualification. So the label encoding, each label is converted into the integer value. Okay, whatever the label I'm having, that is converted into the integer value. We'll create a variable that contains the categories representing the education qualification of a person. Now to implement this kind of thing, just observe here guys, very simple, we are having some handy aspects with respect to Python. Just I'm making use of the data, actually whatever the data I'm having. Let me yeah, I don't have the example, no problem. So just the conversion I'm showing to you guys. This particular conversion, observe here. So just how we'll convert and how we are going to perform. So just we are making use of that transformated training data encoder dot fit transform. Just what we are doing is the kind of the degree 1, 4, 2, 3, 3, 4, 5 like that. Okay, maybe if I'm having the kind of the degrees, just to you can see here the examples: high school, diploma, bachelor, master, and PhD. So all these ones are belongs to high school, and all the seconds diploma, the members who are having the two here. And after diploma, the third thing is bachelor's degree, and fourth one is PG, masters, PG or masters, and this fifth one is the PhD. Okay, because just like that, they are converting the appropriate information to the numbers. So our requirement here is whatever the corresponding value I'm having, then I can easily recognize that 5 means PhD, 4 means masters or PG, 3 means some bachelors, 2 means diploma, 1 is high school. So it's a typical understanding, like, as it is, just it is whenever you are getting PhD 5, masters 4, bachelors 3, diploma 2, high school means 1. Like that, it is going to as it easily convert. Nothing, no logic, nothing. Just it is picking up the data and it is going to post that particular data like 1, 2, 3, 4, 5, and order definitely preserves, guys, because as we are talking about the ordinal kind of thing, just order definitely preserves. And after that, just if you are referencing the other kind of thing, the most commonly used kind of the encoding technique is one hot encoding technique. Okay, because the questions we are getting from this also, and generally we use this kind of one hot encoding in our implementation. Okay, so let us understand this, what exactly the one hot encoding. One hot encoding is just apart from the earlier one in the label encoding aspect, just now we have seen the other consideration related to the one hot is we use this categorical data encoding technique. Okay, so just when the features are nominal, they don't have any order, do not have any order. In one hot encoding, for each value of a categorical feature, we create a new variable. I'll show you guys how to create that and all. Each category is mapped with a binary variable. Binary. Okay, because I'm not going with the unique values 1, 2, 3 like that, because there is no order or there is no need to maintain any rating or something. So we are free to use the binary. Binary means 0 or 1, guys, just to observe. Binary numbers, no? 0 or 1. So binary variable containing either 0 or 1. Here 0 represents the absence. That particular data is not there, and 1 represents the presence of this category. So these newly created binary features are known as dummy variables. Okay, so because they are not actual variables, rather what we are doing is just we are making use of binary values 0 or 1 instead of the actual values. That's what we are naming that as the dummy variables. The number of dummy variable depends on the levels present in the categorical variables. So whatever I'm talking, just let me show you how do we maintain that convention of observing the one heart. Okay, so just to observe here, guys, with this diagram, you can clearly identify what exactly the kind of one heart encoding. Let us try to understand this example. So just we're having some sort of original data. Okay, so we're having some 5 records, and this animal data is there: dog, cat, sheep, horse, lion. In front of the human, they're all equal. Okay, we are having some pets like dog, cat, sheep, horse, lion. Lion we cannot say as a pet. Okay, other than these thing we can have all these all other animals as pets. Now see what this one hot coding does is however the zeroth this zeroth index means first record in Python. Zeroth index, generally we start with zeroth index in Python, of course, which resembles the first record, second record, third, fourth, five. And if you remember guys, actually ILOC is index based LOC, which access these kind of thing. LOC access these kind of things because this access mechanisms. Okay, so location, internal location, if you follow like 0 to n-1, you can use the ILOC so as to pick the data. Otherwise, you can use the LOC user defined 1, 2, 3, 4, 5, 6 like that you can use. Now here, one simple thing is because in the first record, we are having only animal dog. So only that particular thing is we are getting as 1, remaining all 0. That means by seeing this particular one at a particular location, we can confirm that this is the dog. And these are all wrong. And the second one, cat. Only whenever there is a requirement, then there only we are putting some kind of the consideration. Remaining all 0, binary. Na? So here we are at sheep. Now here no and horse. And then here, all these things are no lion. Like that, this particular one hot, what it does is just it is picking up only the corresponding data and it is going to map that particular thing accordingly. Okay, the binary values 0, 1, and whenever there is a presence of the corresponding item, just you can make use of that one. Otherwise, you can make use of that 0. 0 means absence of that one. If you go back now, observe the number of see here in one hot encoding for each level of the categorical feature, we create a new variable. Yes, we have created all these 4, 5. And each category is mapped with a binary variable, either 0 or 1. 0 represents absence, 1 represents presence. Okay, now how simple to implement this particular thing is I have collected that thing also, guys. And now you observe this thing. Actually, maybe if I want to represent this particular thing with respect to the corresponding narration of cities or something. So just I can make use of the convention like this, guys. I'm having a small code with me. Just if you are making use of this convention, like we are importing some sort of the data. So like this, just we are getting this convention. Okay, category encoders and as CE, just we are importing that pandas as PD. Just we are picking up the data pd.data frame. Now what we're doing is city, Delhi, Mumbai, Hyderabad, Chennai, Bangalore, like that I'm having some sort of the data. Now I want to apply the one hot encoding. How to create the object for this encoding is just a ce.one hot encoder columns. So city column and handle unknown, return none. Suppose if any other than these particular data return not a number kind of thing, and data frame, use category names. So if I am printing this particular data, obviously we'll be getting that particular data. So I assume that we are having this particular data as the example. So the city information and all these kind of the convention. Delhi, Mumbai, Hyderabad, Chennai. This is the original data. I assume that. Now accordingly, I need to prepare the one hot encoding. So for that, only one single liner I can make use. Uh, just we discussed like fit and transform, guys. Like just whatever the data item I'm having, just we can make use of that fit and transform. Now you observe here, obviously what it does is just data encoded. Encoder already we have created here with the one hot encoding kind of the reference, one hot encoder. So that encoder dot fit and transform the data, original data what we are having. Now after this particular running of this thing, and if I want to print the data encoded as per your expectation, just we are getting this kind of the outcome. Have a look on this. Okay, like how we have seen our the pet animals like dog, cat, all these kind of things. Accordingly, just we are making use of the cities also. Whenever the first thing is Delhi, actually, if you see the original data Delhi, just it has given that thing as one. So reference to Delhi. And here we are reference to next is Mumbai. Just you can compare with the original data. And this is Hyderabad and Chennai. Likewise, you can maintain the convention. So ultimately, the one hot encoding, just it is going to map the binary value zeros or ones according to the requirement of the corresponding cities or animals or whichever. So this is how you can make use of the convention. But one more problem, one more thing parallel to this one hot encoding is the next highest used kind of the technique is and had a dummy encoding actually. So because we just now we have seen the one hot encoding. Now we are dealing with the dummy encoding. Have a look on this guy. Just you are making use. So for label encoding directly what it does, just it is making use of label encoding is suitable to the ordinal data. Whenever there is a kind of order internally. And if I want to preserve that, definitely I should go with the label. One hot encoding, no order, nothing, just binary. With the binary representation, we are going to make use of that. If the data is not present 0, data is present 1. Okay, and we have seen some example implementation here. And rather than taking the animals, we have taken the city information and all. Now, if you observe the dummy encoding, which is something like the dummy coding scheme is like one hot encoding. It's similar to that. That means one is present, zero is absent. Okay, would you agree? And this categorical data encoding method transform the categorical variable into a set of binary variables, which is also known as the dummy variable. Just now we have seen. In case of the one hot encoding, for n categories in variable, it uses n binary variables. That means, suppose I'm having Delhi, Bangalore, Hyderabad, Chennai, like that four. N variables, it uses the n binary. Like it is taking Delhi, Bangalore, Hyderabad, Chennai. Accordingly, it is making use of the convention. Okay, na guys. So four cities means four binary variables, but this is the important point. Okay, but the dummy encoding is a small improvement over the one hot encoding. What it does is the dummy encoding uses n-1 features to represent the n labels or categories. Suppose you are having 4 equivalent to 4, we need to get in the one hot encoding. Whereas in dummy encoding, we are having only 3. Okay, and reducing of 4 to 3. That means 10. If I am having, if I am reducing to 9, it is also great performance benefit, guys. Okay, here we are coding the same data using both one hot encoding and dummy encoding techniques. And while one hot uses 3 variables to represent the data, where dummy uses the 2 variables to code the 3 categories. Maybe I'm having category 1, 2, 3. And in case of the one hot, I should use 3 variables. In case of the dummy encoding, I can use, I can refer those kind of thing with 2 only. You may ask me, what is the trick? Nothing. So just a technique, guys, here. Just if you are referencing this particular kind of the trick, let me give you the distinction between appearance of this one hot and dummy. Okay, just if you observe this thing, first is the of course example for the one hot. If A is there, then remaining are absent B, C. If B is there, A and C are absent. If C is there, A, B are absent. Now in the dummy encoding kind of thing, if A is there, B is absent. If B is there, A is absent. But what about C? If both are 0, then I can say this is C. Okay, so is a little trick. because this is not using the third variable so as to represent. Just if absent of AB, okay, that means if I'm having ABC values, if I'm saying like this, okay, if I'm saying like this, I can able to observe absence of both the things. Maybe I can make use of this C separate. And if I'm getting all the 2 0 values, okay, even every time I need not refer the third bit actually, if you observe, even in the representation of ABC also, I have to refer the three digits in each thing. But whereas in this particular case, though I'm having the three variables, it is enough to refer only two representations. And if both the values are absent, that means AB, and it is referring to the third one. It's a purely logical kind of the thing, guys, dummy encoding. But maybe, practically, if you observe, how do I refer this dummy kind of thing? There is a representation and you can easily compare. This thing remains same. Category encoders. Here also we have taken the category encoders. And then what we have done pandas as usual. This is a data frame, same data frame. But only the distinction is, let me pull that particular code also. How do I make use of that particular thing? There exists dummies actually. So there is a concept called dummies. Just if you observe this thing, and once we are getting the data and pandas that get dummies, data drop first equal to true, data encoded. Now once this, if you apply this kind of the convention, we'll be getting like this, guys. Just if I am making use of the convention, okay, the outcome is this one. Whereas in the earlier thing, if all the zeros are there, then I can say this is the last thing. Okay, accordingly, because see here, how many things are there here, guys? Delhi, Mumbai, Hyderabad, Chennai, and Bangalore. Now we missed out the Bangalore actually. Okay, we don't have any Bangalore location here. Now, if you observe this kind of the record, okay, whatever the missing is there, fourth one, this is Bangalore. Anywhere it is missed out? No, all the values are there. Now you recheck with our original data. Like if you go back and see the fourth record, yes, this is the Bangalore, and seventh is also, friends. Let me see that. Seventh record is not there, but definitely if seven is there, maybe this thing actually 0 0, that also refers to the Bangalore. Okay, this is the thing how I can make use the dummy and as well as the one hot kind of thing. But clearly, if you observe the implementation wise, no difference, guys. Actually, in case of the one hot, just I'm having the one hot encoder here. But in the dummy kind of thing, just we are making use of in the encoding itself, I can mention the get dummies. So simple mechanism where you can make use of the convention like understanding of the binary and how do I place the binary values and how I can make use of these kind of things related to the dummy kind of things. And by this time, you would have realized some points, guys. The point here is, guys, sometimes they may ask us why we are not using much this one hot encoding or dummy encoding. The point here is simple. Suppose if the number of variables are less, then we are happy with the kind of the encoding. But whereas if your more number of values are there, then there are certain aspects, guys. I have put all these things because we should know that as a data scientist, we should know that while performing the encoding, which are all the limitations also. See, the initially while achieving some sort of the implementing some sort of the models, initial I'm talking about, it is enough to know that data pre-processing techniques, hyperparameter tuning techniques and all. But as the time gradually grows, just we need to have the limitations and what is the best option I can use and best practices, because that's how we need to grow. That's how we need to implement our efficiency. Okay. Now you see here one simple and direct problem with the one hot and dummy is are too powerful effective, definitely, without any doubt. They're also very popular among the data science, but may not be effective as when many levels are present in the data. If there are multiple categories in a feature variable, such as case we need to have a similar number of the dummy variables to encode the data. 30 different values are there, then I need to have 30 for one heart and 29 for dummy. Okay, this is also one of the limitation. If you have multiple categorical features in the data set, similar situation will occur again. The same situation. We learn to have several binary features representing these things. So this is good for less than 10. Okay, and more values if we are having, then obviously we'll end up with some sort of the complexities and all. But what is the problem with this? The problem here is actually there is a problem called a dummy variable trap, guys. Actually, see here, in both the cases, these two encoding schemes use this sparsity. What do you mean by sparsity, guys? Maybe if you have heard about sparse matrix, observe here where there are many zeros. This is a sparse matrix. To handle this particular one, we are having these many zeros. In a matrix where we are having the more number of the zeros, that is called as a sparse matrix. Sparsity in the sense in the balancing of this binary data, more zeros would be there. Several zeros we are having. And only we are having few ones. One means if the appearance is there, then only we are putting one. In other words, it creates multiple dummy features in the data set without adding much information. Here, no information is there, nothing is there, nothing is there like that. So also they might lead to dummy variable trap. Most important thing, guys, because while converting or while transforming your data into the binary things, you should be aware of this dummy variable trap. It is a phenomenon where features are highly correlated. That means using the other variables, we can easily predict the value of a variable. So that means suppose there is a pattern. Okay, there is a pattern. And of course, our algorithm, our model is also habituated to that particular pattern. And if you are giving any new pattern, it miserably fails, guys. Actually, we discussed this point in the overfitting. Rather than learning, if your model is by hearting something, then that is the actual problem. So here also we are having this kind of the approach where there is a kind of the dummy variable trap because just it is leading to the overfitting and some of the variables and these things are forming a pattern which easily expectation is like that only. Okay, so this is high correlation pattern is there, which should not be the good sign to a data scientist and all. Now moving ahead, we are having some solutions for that actually, like solution in the sense other encoding techniques we are having. That is effect encoding, which is a separate aspect, guys. Maybe you heard about label encoding, one hot encoding, dummy encoding, all these things. But in the nowadays, we are using some other aspects also, like target encoding is there that I'll be covering today only. I don't want to split this thing. So the effect encoding is nothing but this encoding is also known as sum encoding or deviation encoding. Effect encoding is almost like the dummy encoding with a little difference. Like in dummy encoding, we use 0 and 1 to represent the data, but in effect encoding, we use the values 1, 0 and -1. Because of that dummy variable trap, they have changed this thing to 1, 0, -1 kind of thing. The row containing only 0 in dummy encoding is encoded as -1 in the effect encoding. That means suppose in the earlier cases, if 3 zeros are there, that means the fourth variable that is. But now instead of this 0, we are putting -1 actually. Okay, rather than maintaining all the zeros and ones, which leads to the dummy variable trap and all. So just we are making use of that particular convention so as to handle the situation. So in the dummy encoding example, the city Bangalore at index 4 was encoded as 0. Whereas in the this effect encoding, we represent them as -1s and all. Because instead of 0, just we are making use of -1. This is purely to avoid the sparse nature. What is the sparse nature, guys? The majority of our values are zeros. so as to avoid and so as to escape from the dummy trap, just we can make use of this sparse nature. Okay, we can make use of the effect encoding. You may ask me, how do I achieve that? Simple, like where we provided with some sort of technique. So same kind of thing on top of the city, we are going to perform some kind of the encoding. This is the simple. We are loading the category encoder, and I am reading some data frame with certain cities data, Delhi, Mumbai, all these kind of the conventions. Now what we're doing here, guys, just if you refer, this is the original data. Let me paste here so that we can have a look on that. This is the original data. And then after this particular thing, just will be having some other aspects like, like I want to transform that. Okay, one simple formula, just even it is a single liner actually. After getting your encoder, just what I'm doing here is just a simple thing. Encoder fit and transform simply. So here category encoders, data frame, city and all these things. And what we are doing is just we are sum encoder. If you remember, this is also known as deviation encoding or sum encoding. What we are doing here, guys, just we are picking up these aspects like I'm having some sort of information like, so just you are converting the data. Now easily you can observe now. This is definitely Bangalore, because rather than 0, we are putting -1 kind of thing. If -1 is there, then it reaches to the Bangalore kind of thing. Purely this is for the sake of avoiding the sparsity, guys. Okay, because nowhere you found zeros here. Okay, to handle that kind of the convention, and now you 0, of course. This is reference of city 1, and this is city 2, and this is city 3. Of course, this is city 4 actually, Bangalore, and though we are not referencing that, but still -1 refers to that particular representation. Now, one more thing is here, again, city 0, and this is city 2. Likewise, it move ahead. So this is how you can refer your encoding, okay, related to the effect encoding or sum encoding, all these kind of the things. Now, one last aspect is there, guys. Nowadays, we are frequently we are using this convention, which is pretty interesting. That is known as the target encoding, actually. So this particular target encoding is very much helpful to us. Just a simple analogy, like this particular target encoding follows the Bayesian encoding techniques. Yes, you are right. Naive Bayes, we have seen the like probabilistic analysis and all those kind of thing. And Bayesian encoders use information from the dependent or target variable to encode the categorical data. Bayesian encoders use information from dependent or target variables. Suppose if you want to take the help of the outcome or dependent or target variable, and based on that particular thing you want to perform some encoding, then go with the target encoding. And in the target encoding, we calculate the mean of the target variable for each category and replace the category variable with the mean, which is meaningful, guys. Like suppose I'm having some data, getting the mean, and we are replacing that. In the case of the categorical target variable, the posterior probability. Okay, because we have seen some sort of the probabilistic analysis where it is giving some sort of information, maybe 60%, 70% or 80% chances are there like that. Let us try to understand the implementation, which is pretty simple and easy. Just the same data we are taking marks data this time, where there is a resemblance of gradings and all. Just if you observe this convention, we are importing the libraries like pandas, and as we are discussing about the category encoders, CE, and data frame we are creating like 50, 30, 70, 80, like that some marks are there. Corresponding, we are having the class A, B, C, like that the corresponding classes. Maybe here we have taken 50 to 80 or something like that is a class A, and 30 class B, C, 70, like maybe some kind of the assessments we are doing. And target encoders we are creating with class variable like ABC kind of thing. At the moment I am printing this particular data, what we are getting is guys, just we are getting the original data. So the appropriate aspect, so just I am making use of this thing. Okay, so 50, 30, 70, 80, all these things. Uh, and don't worry about the ordinal kind of thing. Just it is a kind of representation where 68, 80, 97, all these things belongs to the A grade, but still 50 is also maybe some, definitely there should be some correlation. But our interest is how do we represent this thing? After getting this data, there is a simple conversion technique, guys, not much. That is the main benefit of these encoding techniques. Okay, without much coding, I can implement. Now you see here, just what we are doing here is fit and transform the data. So encoder dot fit and transform. Just you need to give your data and as well as the marks. Then obviously, as per the definition of that particular target encoding, what we are having, just we are making use of this class. Okay, so just we are making use of this particular class and we can perform the activity. Okay, like these 65%, 57, this is a probability, na? The percentage. Okay, likewise, out of those kind of thing, you can observe various kinds of the techniques in the target. Now there are certain points to remember, friend. Probably this is the conclusion I am making. So just 2 minutes, then we'll wind up. So just if you are referencing these kind of the items, uh, if you consider these target encoding, we perform target encoding for trained data only and code the test data using results obtained from the training data. That is the most important thing. Only we are embedding the training kind of thing and we are making use of the training data to test the outcome, because based all the very efficient algorithm, it has the following issues or limitations as that of the one hot and dummy encoding. It can lead to the target leakage or overfitting, definitely, because guys, there is a whenever there is a pattern, whenever there is understanding of the data by the algorithm or model, just it try to follows the same kind of the convention, which is again the problem. Okay, so to avoid that overfitting, some techniques we have to use. In a leave one out encoding, this is leave one out encoding means one particular feature we can leave out. The current target variable value is reached from overall mean of the target avoid leakage to avoid the leakage of that thing. Another method, we may introduce some Gaussian noise in the target statistic. The value of the noise is hyperparameter to the model. Only they are saying that how do we manage this kind of the convention. So the second issue we may face is the improper distribution of the categories in train and test data. In such a case, the categories may assume extreme values because outlier kind of thing or something like that, then it is having a pitfall. Therefore, the target means for the category are mixed with the marginal mean of the target. Okay, which is very important thing. And now the question we got from the examination perspective is, guys, pretty simple. Let me paste here. What is the question we got? Um, Let me show you. Yes, this is the question. Like this, they're asking in encoding kind of thing. Let me the size. Okay. So what is the name of the method that transform categorical feature into a series of binary indicator feature variables? That means we are having the categorical and I want to get the binary feature variables. The first thing should come into your mind is the answer must be, friends, one hot encoding. If they explicitly ask if I want to reduce one variable, if I want to perform some analysis on the corresponding outcome, then you go with the other things, guys. Otherwise, just you can stick on to your one hot encoding. Sometimes if they ask you the posterior probability usage, or if I want to embed the outcome or labels in the encoding technique, then you go with the target. And if you are seeing this effect encoding is some encoding actually. Just we have seen some other kind of the technique, whereas this is the third technique, dummy encoding. Dummy encoding is used to reduce the number of binary values, and this is the effect encoding, which is really helping us instead of zero, because sparsity is also one of the problem. What we are doing, just we are making use of that -1 instead of 0. And then the next technique I am having is the target encoding, which is of course based on the Bayesian kind of the technique. Okay, so this is how you can refer, guys, and I'll come up with some other topic in the next session. Definitely with by covering some of the I mean questions out of this examination. Okay, that's all. Thank you for attending.